5.1 on rate of change and slope. Okay. So some vocabulary. Slope is the ratio of a vertical change, also known as the rise, to the horizontal change, which is known as the run, between 2 points on a line. Right? So vertical, remember, is up and down, horizontal being left and right. So that's why this is called your rise, and this is called your run. Okay? What slope actually tells us about is tells us about the steepness of a line. Okay? How fast that line is going up or how fast it's going over. Okay? It is always written as a fraction, an improper fraction, or a whole number. Okay? And whole number meaning really an integer because it can be both positive and negative. Okay? When we're talking about slope, there's two major methods to find it. The first one is rise over run, which is the most common one to use when you're given a graph. Is on a graph. And the second one is actually called your slope formula, y2 minus y1 over x2 minus x1. And we use this when we are given ordered pairs. One and the y1s and the x2 and the y2 mean is they're telling you how those ordered pairs have to be grouped in the formula. So one of your ordered pairs is written with the subscript of 1, and the other ordered pair is written with the subscript of 2. Okay, so you can see which one goes with which. So when you look at this formula, these first two numbers make one of your ordered pairs, and the second set of numbers makes the next ordered pair. Okay, so lots of times when I refer to the slope formula, I'll just say y minus y over x minus x. And you just need to remember that this is one ordered pair and this is the second ordered pair. There is 4 different types of slope. The most common is you have a positive slope, so as we look from left to right, just like when we're reading a book from left to right, we are going up along that line. Okay? Whereas for negative slope, when we look from left to right, that line is pointed down. Okay? Positive slope versus negative slope. Positive slope going up from left to right, negative slope going down, always from left to right. And you're going to have it being opposite, so you need to remember left to right, just like when you're reading a book. Given a graph. Okay? The way we are going to find it is by using that rise over run. Start at the point on the left side of the graph, and we move to the point on the right side of the graph. Okay, so that's why that rise can either be going up, or if your line's pointed down, it can be moving down. That's how we get a positive versus a negative. So we're starting here at point A, because that's the point furthest to the left. And then we move to point B. Okay, see how these arrows are pointed up and then over, because we're always starting that point on the left. So let's try this one. I look at this line, here's my point to the left, okay? Here's my point on the right. So to find my slope, I'm going to start at this dot and do a rise and a run to get to my other one. What we're really making is a triangle. This side, the up or down part, is your rise, so I can count boxes. 1, 2. And since we went up, my rise is a positive 2. Horizontal line is your run, so 1, 2, 3, 4, 5. Does not simplify, so 2/5 is my slope. rise over run. Most point, that run will always be positive, and that's why we can look at that rise to tell us if our slope is positive or negative. So for our graph, we use slope, or we find slope using our rise over our run. For pairs, like I said, there's a formula, and it's y minus y over x minus x. Again, you need to remember that these two are ordered pairs. These two go together, and these two go together. Okay? They have to be set up that way, or you're not going to find your slope correctly. So if you want to remember the x1 and the y1, we can do it that way. Okay, so this would be x1, this would be y1, this would be x2, and this would be y2. Doesn't matter which one you label which, it will work out the same either way. Okay? So what's the slope of the line? Going through 1, 3, and 4, negative 1. I'll write my fraction bar, my division sign, okay? And I'm going to write down that first order pair. The y goes on top, and the x goes on the bottom. Okay? Slope formula is always subtraction. Okay? Then I look at the next order pair. The y is a negative 1. Remember that if it's negative, it should be in parentheses if it's after an operation. And the x coordinate is 4. So it's y, the 3 minus a negative 1, over the x's, which is 1 minus 4. Okay? So when I take 3 minus a negative 1, this becomes a positive. So I really have 3 plus 1, which is 4. And 1 minus 4 is negative 3. Okay? Which when we write an actual slope, remember we never put, or a fraction even, we never put that negative in the denominator. You need to either write it in your numerator or out front of that fraction bar. So for this set of ordered pairs, my slope is a negative 4/3. Okay? And like I said, you can really start with either ordered pair, so I'm going to do this one the other way just to show you get the same answer. Okay? So if I flip-flop these, and this time I'm going to start with the second order pair. Okay? So my y coordinate there is negative 1. X coordinate is 4. Rule is still subtraction. Okay. Second order pair, my y coordinate is 3. X coordinate is 1. So this time I eliminated that double negative. But when I do the actual math, negative 1 minus 3 gives me a negative 4. And 4 minus 1 gives me a positive 3. So my slope, no matter which way I set up that problem, ends up being the same answer of negative 4/3. So let's look at the second one. Come on, we just did it up there. Okay. So on your homework, you should have actually done this part. Alright, so the other two, like I said, there's 4 major types of slope. Positive, negative, and these are the next two. We have horizontal and vertical lines, which have special types of slope. Okay? If you have a vertical line, you are said to have an undefined slope. When you have a horizontal line, you are said to have a slope of 0. Show you where those come from, okay? If we were to look at this line, okay, there's infinitely many points on a line. So if I put a point right here and a point right here, to do my rise and my run, okay, I can find a rise by going up 2, okay, which would be the top number in my rise formula, but there is nothing to go over, so I end up having a run of 0. Okay? And if you think back to our different sets of numbers, can I actually take 2 divided by 0? Okay. Can I split 2 into nothing? No. This is an imaginary number, which means it's an undefined slope because this is imaginary. It doesn't actually exist. Whereas when I look at a horizontal line, okay, I can put dots anywhere on that line. Whenever you're finding slope on a graph, you can use any 2 points on that line, and it will always work out, right? If they're giving you dots, use that. If you need to put your own dots, but make sure they're in between the cross points on the coordinate plane. So when I look here, this time there is no rise. So that top number for my slope is going to be 0, but my run, for me, is 3. And no matter where you would have put your dots, you would have ended up with a number down here. Okay? But the thing about this one is you can actually take 0 divided by something, and you end up with 0. Okay? So this one really does exist. Okay? So these can be identified with your slope formula too. Okay? So if I look down here, if I do y minus y over x minus x, that remembers our slope formula. Have -3 for y and 4 for x. Subtract. Second order pair, 2 for y and 4 for x. -3 minus 2 gives me a -5. 4 minus 4 is 0. Okay? So right here, since that 0 is on the bottom, I can tell you this line would be undefined. Final answer for that type of slope. Lines. Okay? This one I didn't put the dots on there, but remember I said they had to go through points on that coordinate plane. Okay? So if I were to look at this one, starting the point furthest on the left, I'm going to go down 1, 2. This one we went down 2, and then I'd be going over 1, 2. Over, run. We went down, my slope would actually be a -2, and my run would actually be a +2. And then anytime we move to the right, it's always positive. As long as we turn at the left, dot, that's always going to be a positive on the bottom. Now for this slope is not simplified. Okay, -2 divided by 2 simplifies to a -1. So this first graph has a slope of -1. Okay? The second graph, okay, we need to remember about this type of line is vertical, which means I'm not going to have a run. So it's going to be over 0, which means my slope is undefined. Okay, again look here, there's going to be no rise, so it's going to be 0 over a number. So this one has a slope of 0. Okay. Going through those points on the coordinate plane. So from the left, 1, 2. This time we went up 2. And then here we went over 1, 2. My rise is +2. Run is always positive as long as you start at the left. And 2 over 2 simplifies to 1. Okay? So if we look at these lines, okay, this one, as we move from left to right, is pointed down. So we know our answer should end up being negative. This one, as we look from left to right, is pointed up. So we see that our answer should be positive. Of change. Okay? Okay? This is very, very closely related to slope. Right? Well, the only difference is that this is what we use for a word problem. Right? In a word problem, they're not going to tell you to find the slope of the graph. They're going to ask you what the rate of change is. And what a rate of change definition is a quantity showing the relationship between two changing quantities. Okay? So how they refer to it for a formula is your change in your dependent variable over a change in your independent variable. So if you think back to the functions chapter we just did, remember your dependent variable is always y, and your independent variable is always x. So another way to think about rate of change is your change in y your change in x, rather than thinking about independent and dependent. It's a lot easier for some people to think about change in y over change in x. Okay? And since rate of change is focused on word problems, the other thing we have to remember about rate of change is it's always labeled using the word per. Okay? So if I look right here, 65 miles per hour is actually a rate of change. It's comparing the two quantities of miles and hours. Okay, so rate of change. A word problem. Okay, the table at the right shows the distance a band member marches over time. The rate of change from one row of the table to the next is 260 feet per minute. Do you get the rate of change of 260 feet per minute if you use non-consecutive rows in the table? So right here they're telling me the change from one row of the table is 260 feet per minute. Right? From 260 to 520 is a change of 260 over 1. Okay, and this one, the time is 1. So that 260 was found by taking 260, the change in the independent, remember tables are x and y, sorry, the change in your dependent, right, your y, over your change in your independent of x, which we got to be 1, right, which simplifies to 260. So what they're asking me is, do you get the same rate of change for 260 feet per minute if you use non-consecutive rows of the table? Okay, so let's actually take a look right here. If I go from 520 or to 520 to 520 to 520 to 4, 1040, do I get that same rate of change? Okay, and so what I need to figure out is the change from 520 to 1040, and that is a change of 520. And over here, from 2 to 4, it's a change of 2. Now make sure if you're doing rate of change, you look if your numbers are going up or if they're going down, because now your change in x could end up being a negative number, or your change in y could end up being a negative number. They're going down, they're going to be negative. They're going up, like this one, they're going to be positive. So to find my rate of change, remember it's change in y over the change in x. Is 520. And when I simplify that, you do the division, you get 260, which is the same we got before. Okay? So what this is telling me is that yes, okay, we do get the same rate of change. Is no matter which 2 points you get on a line, your slope will always be the same. Okay? So the rate of change or the slope of a line is the same as your rate of change. Points on a line. And that's the biggest thing, is no matter which 2 points you pick, you're gonna get the same answer. First two or the last two, or the first one and the last one. When I do that division, your rate of change is always the same. calculated the slope of a line at the right to be 2. Explain the mistake and what is the correct slope. Right? So look right here, they have my triangle drawn for me. They started at the right, okay, or the point at the left, and they ended up at the point on the right. Okay? This time, I always do my rise over my run. Okay? But what they did was they moved this way, over, and then up. If I think about my formula, it's rise over run. So the way they did it in their work, their rise is up 1, so it should be 1 over 2. Horizontal, remember, is always your run. Vertical is always your rise. So I got a slope of 1/2. So what they're asking me is what was their mistake? So this right here is the correct slope. A, get a slope of 2 would be to end up with 2 over 1 because that simplifies to 2. And if they did that, what they actually did was they put their run over their rise. Their rise over the run. Okay, so they reversed their formula. And that's why it's important you always think about how you draw your shapes. And you know that the vertical change is your rise, the horizontal change is your run.